Of course it would end on that clip.
Thank you for the subscription.
Hey, Security Live, thank you for the sub. How you doing, dude? 365, yeah. Literally, just continuing is going to get me it. So, yeah, I picked one of the free rooms that we've got left. So we've got bypassing UAC. We're going to learn how to do the common ways to bypass UAC controls in Windows. And I'm going to turn the music down before I start losing my mind. Oh, I don't know if you saw actually in Discord. Get Discord up. Yeah, I posted a chat in there just showing you what I get come up when I launch the new or the old bot. I just get a white screen, and then if I do inspect, there's like some kind of token that isn't being passed to where is it? The voices. So. I don't know what causes it, but I'm guessing there's something that has run out or like an auth missing. It's melting too hot for it today. I had that problem when my system time was off by an hour. So mine's not off by an hour, but I'm in the UK, so maybe that's it. Maybe I'll try and set my time to a US hour and see if that sorts it out. But yeah, I'll let you know. Cool, right, should we crack on and do the room? Hey, Entertainment. So in this room we're going to be looking at the common ways to bypass a security feature available in Windows known as the User Account Control, or UAC. This feature allows any process to run with a low privilege independent of who runs it. From the attacker's perspective, bypassing UAC is essential to breaking out of a highly restrictive environment and fully elevating privileges on the target host. While learning of the bypass technique, we'll look at how any alerts that could be triggered and the artifacts that may be created on the target system that Blue Team can detect. So we're going to learn the different techniques available to attackers to bypass UAC, and it's recommended to go through the Windows internal room, which we've already done. Should be relative to your location for signatures. You shouldn't going. Oh, cool, no worries. Alright, ready? Let's see my. Complete. We've got 365 days. Yay! I don't know if that's giving me the badge straight away. We'll find out after. Alright, so UAC. The user account control is a Windows security feature that forces any new process to run in a security context of a non-privileged account by default. This policy applies to processes started by any user, including the administrators themselves. This idea is that we can't solely rely on the user's identity to determine if some actions could be authorized. Although this may seem counterintuitive, imagine the case where a user Bob unknowingly downloads a malicious application from the internet. If Bob is part of the administrator group, any application they launch will inherit his token privileges. If Bob decides to launch the malicious application and UAC is disabled, the malicious app will gain admin privileges instantly. Instead, the malicious application will be restricted to a non-administrative access token when UAC is enabled. So this is what it looks like. If an admin is required to perform a task, a privileged task, the UAC provides a way to elevate the privileges. Elevation works by presenting a simple dialog box to the user to confirm that they explicitly approve running the application in the administrative security context. So we've all probably seen one of these. This is like from Vista era. So the integrity level. UAC has a mandatory integrity control, an MIC, which is a mechanism for allowing the differentiation of users, processes and resources by assigning an integrity level to each of them. In the general terms, users or processes with a higher integrity level can access tokens, or higher integrity level access tokens will be able to access resources with lower or equal integrity levels. MIC takes precedence over regular Windows DACL, so that you may be authorized to access a resource according to the DACL, but won't matter if your integrity level isn't high enough. The following 4 integrity levels are used by Windows, ordered from lowest to highest. So we've got low, generally used for an interaction with the internet, has limited permission. Medium is assigned to a standard user's administrator's filtered token. High is used by the administrator's elevated token if UAC is enabled. If UAC is disabled, all admins will use the high token. And system is reserved for system. When the process requires an access resource, it will inherit the calling user's access token and its associated IL. The same occurs if the process forks a child. So filtered tokens. To accomplish the separation of roles, UAC treats regular users and admins in a slightly different way during logon. Non-admins will receive a single access token when logged in, which will be used for all tasks performed by the user. The token has medium IL. Administrators will receive 2 access tokens, a filtered token with admin privileges stripped used for regular operations. This token has medium integrity level. And then medium tokens, the token will have full admin when it's used with something that needs to run as administrative privileges. This token has high IL. In this way, administrators will use their filtered token unless they explicitly request admin privileges. So, opening an application the usual way. When trying to open a regular console, we can either open it as a non-privileged user or an administrator. Depending on our choice, either a medium or a high integrity level token will be assigned to the spawn process. If we analyze both processes using Process Hacker, we can see the associated token and their differences. This is cool. So on the left you'll see the filtered tokens with medium IL and no privileges assigned. On the right you can see that the process runs with high IL and has many more privileges available. Other differences that they may not be so obvious is that the medium IL process is effectively denied any privileges related to that being part of the administrative group. That's cool. I don't think I've ever spent time in the token section of this panel. Yeah, elevated, no, yes. UAC settings. Depending on our security requirements, UAC can be configured to run at 4 different notification levels. To always notify, whether we notified and prompt the user for authorization when making changes to Windows settings, or when a program tries to install the applications or make changes to the computer. You can notify me when a program tries to make changes to my computer. This will notify and prompt the user for authorization when the program tries to install apps or changes. So it's basically just stripped of the other setting. Like Windows. Administrators won't be prompted when changing Windows settings. Okay. Notify me when the programs try to make changes to my computer. Do not dim my desktop. Same as the above, but it won't run the UAC prompt. Never notify, so we'll disable the prompt altogether. Admins will run everything as high privilege token. That I've seen before. I've never actually tampered with it. Just leave it as high, right? Always notify. Right, from the attacker's perspective, the 3 lower levels are equivalent, and only the always notify setting represents a difference. At the heart of UAC, we have the Application Information Service, or App Info. Whenever a user requires elevation, the following occurs. The user requests to run the application as an administrator. A shell execute API call is made using the run as verb. So this is this bit. And then the request is forwarded to App Info to handle the elevation. The application manifest is checked to see if auto elevation is allowed. More on this later. App Info executes consent.exe, which shows the UAC prompt on a secure desktop. Secure desktop is simply a separate desktop that isolates processes from whatever is running in the actual user's desktop to avoid other processes from tampering with the UAC prompt. That's interesting. And finally, the 6. Oh, I've clicked on the thing. If the user gives consent, it will run the application as admin. The user app info service will execute the request using a user elevated token. App info will then set the parent process ID of the new process to point to the shell from which elevation was requested. So to bypass it, from the attacker's perspective, there might be a situation where you need to get a remote shell to a Windows host by PowerShell or CMD. You might even gain access through an account that is part of the admin group, but when you try to create a backdoor for future access, you'll get the following error. System error 5 has occurred. By checking our assigned groups, we can confirm that our session is running with a medium IL, meaning that we're effectively using a filtered token. Even when we get the PowerShell session with an administrative user, UAC prevents us from performing any administrative tasks, as we're currently using a filtered token only. If we want to take full control of our target, we have to bypass UAC. Interestingly enough, Microsoft doesn't consider UAC a security boundary, but rather a simple convenience to the administrator to avoid unnecessarily running processes with admin privilege. In that sense, the UAC prompt is more of a reminder to the user that they are running with high privileges rather than impeding a piece of malware or the attacker from doing so. Since it's a security boundary, any bypass technique is not considered a vulnerability to Microsoft. How convenient. And then, therefore, some of them remain unpatched to this day. Generally speaking, most of the bypass techniques rely on us being able to leverage a high IL process to execute something on our behalf. Since any process created with a high IL parent process will inherit the same integrity level, this will be enough to get you an elevated token without requiring us to go through the UAC prompt. For all the scenarios presented in the room, we'll assume that we have access to the server with an admin account, but with a medium IL console only. Our goal would be access a high IL console without going through UAC. So what is the highest integrity level available on Windows? System. What is the IL associated with the administrator elevated token? High. What's the full name of the service in charge of dealing with UAC elevation requests? I can't remember the name of it, but we can go off and copy it. It was... I've forgotten the question already. What was the name of the service in charge of dealing with UAC elevation? It's not that, because it's more than 2 words, so... Suggest a poll. Is the streak for real? Hell yeah. Get my profile up. Actually, we can see if we got the badge. Hey, there we go. So yeah, look, if you got there's some gaps in it. I don't know what that's about. But yeah, something like, don't feel ashamed if you've only got like 2 events some days. If you're trying to do it as well, like some days I've got like 154 on that day. 59. $74-day streak here, nice. Yeah, I started in the what was it? The Try Hack Me Christmas thing last year, and then I lost my streak, and then I had to restart it about this time last year. So you have gaps too, even though you did stuff on that day. You can actually email them if you've got a gap. You can say, hey, this day didn't get counted, and the support team generally fix it. Have I got a background in cybersec? Yes, I work in the cyber industry. I've done app security, information risk management, like risk control, like or GRC. Like I've done a fair few things. So I don't do. I'm not really in a red team, so most of these things have been completely new to me. You're a complete noob. Well, welcome in. So we're all noobs. You never stop being a noob. That's the great thing about this sort of sector. Like, right, go away, Weapalizer. We don't care. Like, I'm currently being a noob trying to find out the name of this service. So. UAC. Let's see if we can just cheat. User account control might be that. Weapalizer. Oh, that's just a recon tool, Weapalizer, so you can see what's running on websites. What's great, man. I'm enjoying it so far. Down the road, we'll be going to the OCP, like way down the road. Yeah, I think I might join you on that one because I'd love to get my OCP. Like, it's one of the one things that I would like to do is a lot more offensive training. Like, I'm doing lots of cloud stuff at the moment, but yeah, definitely next after my cloud certs is going to be OSCP for sure. Even if I don't use it in my day job, it's just going to be one of those ones that I want to get. Why am I being so dumb with this? Like, what? We've got 7 words or 7 characters. Oh, that might be it. At the heart of UAC, we have the Application Information Service, or App Info. Okay, so it was this, but they've shortened it, so I completely skipped it. So I want the full name. There we go. Cool. The new SCP is better, at least at first. Yeah, aren't they dropping? They've gotten rid of buffer overflow. I don't know if that makes it easier or not, because they're only going to throw in something else. Right, let's start this box. The one thing that scares me a little bit about the OCP is that you can't use like the automated tools like LinPs and stuff. And that's like my go-to for CTF boxes. So yeah. Just have to have a cheat sheet with all the things in there, and then you just manually do LinPs one by one. Alright, so we're going to start by looking at the GUI-based bypass. They provide an easy way to understand the basic concepts involved. These examples are not usually applicable to a real-world scenario, as they will rely on us having access to a graphical session. So click on the Start Machine button, get the access with login as attacker, password 321. Right, let's get Ramina. You're allowed Lin Peas and Wimpy. Oh, I heard different. Like I said, I haven't done it, so I haven't got a fucking clue. But I could have sworn that that was one of the automated things they denied. And you're only allowed to metasploit one box as well. It took a look at that message, and it's different as a time. It is different than a time drift issue. It's possible that the old API key is cached somewhere. You could try clearing your browser cache. Look into applying a never cache policy on CloudFront. Cool. Yeah, it's probably a CloudFront thing then, because I've definitely cleared. I deleted all the cookies, all the local storage stuff, completely refreshed the page. So maybe CloudFront is sending me a cache thing. Okay, so you changed the keys last week. That would make sense. Okay, I can try again. I can. I've tried different browsers as well. So I never use Edge for anything, and I tried it in Edge, and I get the same thing with Edge. Hit me up offline another time. No worries, mate. Yeah, Metasploit is allowed on one box. Alright, maybe I'm wrong with Limpy's stuff then. But yeah, I don't understand why Metasploit's only allowed on one machine. Surely you could, if the access is there. Anyway. Right, it's been 3 minutes since I started, so we should be able to get connection. Let's try. Yeah, okay. Attacker. What's the password? Password 321. Only one box, but not the AD box. Ah. I just don't know if that's a realistic way of testing someone, you know what I mean? If you get in and you're using the Metasploit box, or the Metasploit framework to do it, who cares? You still got on the box. I just don't see why that's specifically tested. Why they want you to do everything manually. You going to resize? There we go. Alright, so the case study, msconfig. The goal is to obtain a high-level IL command prompt without passing through UAC. Let's start by opening msconfig either from the start menu or the run dialog. So msconfig. Right, if we analyze the msconfig process with process hacker, we get a UAC for that. Alright, so we should be looking for the... There it is. Let's move it down the bottom. So we can see that even with no UAC prompt presented, msconfig is running with a high IL process. This is possible thanks to a feature called auto elevation. This allows specific binaries to elevate without requiring the user interaction.
Thank you for the subscription.
Thank you for the Prime Savelotti. So yeah, where was I? If we force the msconfig to spawn a shell for us, the shell will inherit the same access token used by msconfig, and therefore it will run as a high AL process. By navigating to the Tool tab, you can go Command Prompt and Launch. So we should see, yeah, there we go. So the child process has a high IL. You're not allowed to proxy or anything like that. Also, it doesn't work when the first try you're done, which is stupid. Oh really? So you can actually burn your use of Metasploit. That's pretty shit. And I bet this is the idea of that Jim guy from OffSec who thinks he holds the absolute truth about everything cyber related. Just because he's OffSec since the beginning and rejects all possible suggestions from the community. He's holding community talks and stuff like that. Yeah, that's pretty stupid. I would have thought they'd care more about the fact that you can get on the boxes, not how you go about it. Like you could technically use ChatGPT to do it all. You've still done it. You might not know what you're doing, but you can do it. Right, so to retrieve the msconfig flag, now that we've obtained the high integrity console, we execute that. You're not allowed to use your AI, of course. Of course. Right, why won't you let me come? So flags, get flag, msconfig.exe. There we go. Submit that. Today's the day, eh? Yeah, we've just done it. Right, the next one. Case study, Asman. As with msconfig, asman.msc will auto-elevate without requiring user interaction. If we can find a way to spawn a shell from that process, we'll bypass UAC. Note that unlike msconfig, azman.msc has no intended built-in way to spawn a shell. We can easily overcome this with a bit of creativity. Let's run asman. So let's close these two. asman.msc, that's already in the list. Do you want to see it, Nick? Look at it. Look at it. I've just got to get the rest. And some of them are like nigh impossible. Right. Yeah, these are the ones I need to get. Act of kindness, God knows how you get that. I've got to be the top hacker, which means you've got to do like every single box every single day. I'll just automate all of the flag submissions. Throwback, that's a paid lab, so that ain't happening. Wireshark, I could do that one, that's quite easy. Docker, we could do those. Hololive, we could do. Investigations, we can finish. And the AD rooms, we can do. So I can do everything except Act of Kindness and Monthly Hacker. Those two are the like the challenging ones. You did Wireshark, yeah. Right, so we got Asman. We can confirm that the process has high IL, because, well, I can see it behind the thing. There it is. To run the shell, we'll need to abuse the application's help. We used to do this at school with Microsoft Office. So Office would spin up services as high IL, and then you could open, like the open dialog to open new files would be high IL. So you just start browsing through the admin folders, and then open whatever you want, and it would open it with the high IL still. So now on the help screen, we can view the source. Now we've got a notepad with high IL. And we can leverage this. Oh, there we go. It said it. File open. So you go file open. Old school. And now go to System 32 and search for CMD. That's quite funny. It's literally what we used to do at school. I can find it. Where are they? All files. Well, that didn't work. Open. Oh, I opened it with the fucking thing, not the open prompt. There we go. There we go. So now we check this one. It's got the high level of access. So what does it want us to do for the flag here? So do flags get flag azman.exe. B. Cool. Yeah, it's quite funny. So yeah, we do that with like the Office suite instead of Asman. You don't. I guess that's a misconfiguration on my school's end of running all the Office suites as admin. But don't do that if you're a school admin. Right, let's close you. Close you. Close you. So next up, we've got auto-elevating privileges. As mentioned before, some executables can auto-elevate, achieving a high IL without user intervention. This applies to most of the control panel functionality and some executables provided with Windows. For an application, some requirements need to be met to auto-elevate. The executable must be signed by a Windows publisher, Microsoft Office. The executable must be contained in a trusted directory like system root or system 32 or program files, Office. Depending on the type of application, additional requirements may apply. Executable files.exe may declare the auto-elevate element inside their manifests. To check a file's manifest, we can use SIGCheck, a tool provided as part of the internal suite. You can find a copy of SIGCheck on your machine on the tools directory. If we check the manifest for msconfig, we'll find an auto elevate property. So let's do that. Tools, there we are. So sig check. Let's try and run it and see. There it goes away straight away. So we'll get another terminal. CD. It's in that direction. CD tools. Sig check. Got to get back on Try Hack Me at some point. Taking a break after having to give a presentation at work. It stressed me out. I've got to do one more thing for another team, and then I'll be free. No worries, mate. Well, like, I mean, you've seen. I'll do like one thing if all I can do is like to keep the streak alive. You just sign in and say yes to something, like, and then walk away and come back to it when you've got time. I don't think there's any shame in that. You can't be expected to do like 50 plus submissions a day. Hey Ghost. Keep the easy questions, you got to click for another day. Well, my trick, I'll show you on it. Oh, let's go. Let's take a little detour for a sec. So you don't even need easy questions. If you just literally just want to keep the streak alive, you've got this room. So the tutorial room, you can reset your progress. And there's only one question. So you just type flag connection verified and you pass the room. And that counts as a daily streak thing. So if you are like it could be 5 minutes to midnight, and you could be on a train coming back home from somewhere. You're not going to get home in time to do to do a proper lab. Just log in on your phone and do that, and you'll keep your streak alive. So you don't need to do anything else. You just need the MSec secret source, yeah. Well, that's it, right? You've got to use everything to your own benefit. There's no point missing out just because you can't be physically attached to a vendor product 24/7. That's what I do roughly, but I do new boxes. That's fair enough. Yeah. Yeah, some of them, they're like the join room button, that counts as well. So just joining the room and clicking, yeah, I know how to connect to the VPN. That'll get you a tick up as well. So. Right, so what we're doing with sig check. So we're going to inspect the msconfig. So do -m Windows. Not going to autocomplete. Oh. System 32 msconfig.exe. You finished the Pentest Plus yesterday. Was actually useful. Yeah, I did. I've done that one. That was really useful. You were so close to 30 days. Oh, slacker. It does happen. Sometimes you just forget. So yeah, you just. Oh, you could technically script it. Just have some curl requests, resetting and submitting a flag. if you really want to break the system. So what we're looking for in here is this auto elevate tag. So you should see there it is. So the mmc.exe will auto elevate depending on the MSC snap-in that the user requests. Most MSC files included with Windows will auto elevate. Windows keeps an additional list of executables that auto elevate even when not requested in the manifest. This list includes package manager and spinstall.exe. COM objects can also request auto elevation by configuring some registry keys. So the FOD helper. FODhelper.exe is one of Windows' default executables in charge of managing Windows' optional features, including additional languages, applications not installed by default, or other operating system characteristics. Like most programs used for the system configuration, FODhelper can auto-elevate when using default UAC settings, so that administrators won't be prompted for elevation when performing standard admin tasks. While we've already taken a look at the auto-elevate executable, unlike msconfig, FODhelper can be abused without having access to the UI. From the attacker's perspective, this means that it can be used through a medium integrity remote shell and leveraged into a really functional high integrity process. This particular technique was discovered by WinScripting and has been used in the wild by the glooptiber malware. What was noticed about FODhelper is that it searches the registry for a specific key of interest. When Windows opens a file, it checks the registry to know what application to use. The registry holds a key known as the programmatic ID for every file type. Where the corresponding application is associated, let's say you try to open a HTML file, as part of the registry known as HKey class's root will be checked so that the system knows that you must use your preferred web client to open it. The command to use will be specified under shell open command. A subkey for each file's prog ID, taking the HTML file prog ID as an example. So HTML file shell open command, and the default is iExplorer because people don't know how to launch Chrome. Right. So system-wide file associations are in the HKey local machine software classes. User file associations are in the HKey current user software classes. When checking a HKey class's root, if there is a user-specific association at HKey current user, it will take priority. If no user-specified association is configured, then it will use the system-wide association. This way, every user can choose their preferred application separately if desired. Going back to FODhelper, we now see that when we're trying to open a file under the MS settings prog ID, by creating an association for that prog ID in the user's context under HKCU, will override the system-wide association and therefore control what command is used to open the file. Since FODhelper is an auto-elevate executable, any subprocess it spawns will inherit its high-integrity token, bypassing UAC. So to put it all together, we need an attack shell, to connect to the back door you can use the following. So we're not using a listener, that's weird. So 37829999. Okay. Okay, I didn't read that bit. So one of our agents has planted the backdoor on the target system for your convenience. He managed to create an account with the admin group, but UAC is preventing the execution of any privileged tasks. To retrieve the flag, he needs you to bypass UAC and get a fully functioning HiIL shell. So we connect to the backdoor, and then we can check if our user is in the admin group and that it's running with medium integrity. So who am I? Net user attacker find local group. So we're in the admin group, and then who am I? Groups find label. We've got the medium mandatory label. We can set the required registry value to the associated MS settings class to the reverse shell. For your convenience, copy a SOCAT can be found on the tools SOCAT, so you can use the following command to set the required registry from the standard command line. Let's see if I can copy that in. So we set that registry key. Ooh. So HKCU, software classes, MS settings, shell open command. And then CMD equals PowerShell, Windows style hidden, SOCAT. So we've got a SOCAT listener. We need to change this to me. Of course, it's not going to let me type 10.8.74.142. And we need a new listener. Actually, we can stick you down the bottom and then stick you at the top. Okay, so we run that. So that creates the command that we're going to run. We add another registry key. Oh no, sorry, so this is just setting some variables. This is then creating the registry key with the variables that we specified. And this is the second one with the CMD in it. And then notice that we need to create an empty value called delegate execute for the class association to take effect. If this registry value is not presented, the operating system will ignore your command and it will use the system-wide class association instead. We set up the listener by, yes, we've done that, and then proceed to execute FOD helper, which will then in turn trigger the execution of our reverse shell. So we can just do FOD helper.exe. Ta-da! Then we can say who am I / groups. Find label. Now we're high. The receive shell runs with high integrity, indicating that we have successfully bypassed UAC. To retrieve the flag for FOD helper, you should need to execute that. Let's pop that in. Keep in mind that the flag will only be returned if you've successfully bypassed UAC via FOD helper and not from the resulting. So yeah, if you're trying to do it in the low shell. See what it does. Process needs to be run with high. There we go. Right, so to clear our tracks, as a result of executing the exploit, there are artifacts we created on the system in the form of registry key. To avoid detection, we need to clean up after ourselves by deleting the registry key. So we say reg delete and we'll clear it out. There we go. Be sure to execute the given command to avoid any artifact interfering with the following tasks. Right, next up, so improving the FOD helper exploit to bypass Windows Defender. For simplicity, the machine that we're targeting has Windows Defender disabled. What would happen if it was enabled? First, using the GUI connection to our desktop, double-click the following icon to enable Windows Defender. So let's get rid of you, so we can enable Windows Defender. Hard mode activated. Right. So now try exploiting the FOD helper again through the backdoor connection and see what will happen to the server's GUI. I mean, does it matter if I've already got the shell lit? Right, let's cancel it to another listener. And then make sure you change the default value and insert your reverse shell. Just told me to delete them. Why have I got to now re-add it? Damn. Yeah, so now if I do FOD helper, it's not going to do anything because it's just going to pop it up. So I've got to re-add fucking keys again. Right, these ones. So let's reset the command. I don't get why it told me to do this and then delete them if it's just going to make me do them again. Now I've got to set my fucking IP again. What the Foz is lurking. Thank you for the lurk, mate. Right, so now we've re-added them all. Let's move this out of the way just in case it like flags anything up. So we want listener over here, and then if we do FOD helper .exe, nothing's popping up. There we go. So we got it anyway. So we got a virus found. It's not telling me where it is. Threat history. Let's try again. Really? Okay, that's strange. So it's not popping anything up. It's not even saying that there's a virus now. It's just weird. UAC bypass, here we go. So there we go. So it's found the command that we set. It says it's removed it, so it's probably gotten rid of the reg key. Software classes. So settings there, shell, open, command. Yeah, there we go. So it's blanked it out. Three followers to go to 600. Whee! I can remember when I was like struggling to get 50. Like, genuinely don't know how it's now like 600. Only way is up, baby. Right, so Defender has killed our thing. Click the notification. Okay, so this is what I just did. So I didn't even need to. Don't know why I bother like reading the walkthroughs. I just end up doing it myself. Alright, so if you query the corresponding value on the registry, you'll notice it's been erased. Although by now it would seem that our exploit wouldn't work with Defender enabled. Let's check what happens if you run the same command but with a slight modification and replace your IP address where needed. So, where's my dodgy box gone? There we go. Oh, I just got rid of it again. So now we can say, let's just copy the same things in again. So attacker IP. Seven 4.142. Pro tip: use the URL bar to modify stuff. Right, then we paste the delegate execute in again and paste that in again. Am I down for some Watch Dogs 2 later this week? Yeah, definitely. Yeah, I need to re-download it again actually because I've, well, you know, I rebuilt my laptop, so I need to install it. But yeah, it's all working now. So, ironically, we've got no drop frames at all, whereas last time I was getting like all my frames dropped. So if we had a quick query of the offending registry value after setting it to the command required for our reverse shell, surprisingly the query outputs our command intact. We still get alerted by Windows Defender, and a second later the offending registry value gets deleted as expected. So yeah, there we go. I don't get the pop-ups, but it's doing it, so... So what was dodgy about that? The query outputs, you still get alerted. It appears it takes a moment for Windows Defender to take action on the exploit, so let's set a reverse listener on our attack machine. And modify the exploit to run FOD helper immediately after setting the registry value. Ah, okay, so that's sneaky. So you're immediately triggering a FOD helper and trying to sort of like a race condition against the threat. So before that it gets a chance to remove the thing, it's triggering it. So we modify the exploit to run FOD helper. If the command is quick enough, it will work and it will replace your IP where needed. Sick. This is quite cool. I like this. So we set that reg key. .8.74.142. So this is also why we're saving them as values, because we need to like set the key like immediately. So now we say reg key. So this is what we did before, and then we're tacking on FOD helper at the end with the ampersand. So ampersand FOD helper should run it straight away. So if we're listening still, which we are, oh, it caught it, bastard. Depending on your luck, FOD helper might execute before the AV kicks in, giving you back a reverse shell. So let's try it again. I've obviously got too quick a Windows box. Oh, no, it worked. Took like 7 attempts. So yeah, it's still blanked out there. Windows has done its job. How bullshit is that? That's well good. So the Defender, although it's like stopped the vulnerability, it's still got me in. That's not. Yeah, that's mad. Got a new battery and some screws in my laptop. It's running pretty hot. I'm going to replace the battery, pull out the motherboard, and blow out the heatsink. Mate, if you want a battery, there's my battery for my laptop. It's not even in there because it. Well, you can see it's like inflated like a balloon. It's not too bad now. Yeah, I run my laptop without a battery because it's fucking puffed up. It was like pushing the where the mouse pad is, the trackpad. So it's pushing the two like clamshell parts of the laptop apart, and you couldn't click the mouse pad, like the trackpad wouldn't click in. So yeah, I just opened it up and threw it away. Good one, Razer, for your quality products. It's like £70 for a new battery off Alibaba. Well, thank you for the bits.
Mr. Destructoid.
I didn't know that did text to speech, that's cool. I think you're the first cheerer. Yeah, you are, yeah. Well, congrats on being the first cheerer on the channel. So we did this, so we were lucky with that one. Windows Defender will still alert about the bypass, however. The problem is with our current exploit, it gives a little room for variations. We need to write a specific registry key for it to trigger. This is easy for Windows Defender to detect, but there's still something that can be done about it. To improve the exploit further, this was proposed by Veded, where a different registry key is used, but the basic principle is the same. Instead of writing the payload into classes shell open command, we can use the current version entry to enter a prog ID registry key. This entry is used when you have multiple instances of an application with a different version running on the same system. Current version allows you to point to the different version of the application to be used by Windows when opening a given file type. To this end, it will create an entry in the registry for a new prog ID of our choice and point to the current version entry in the msconfig prog ID to our newly created prog ID. This way, when FOD Helper tries to open the file using the MS Settings prog ID, it will notice the current version entry pointing to our new prog ID and check it to see what command should use. The exploit code proposed by Veded uses a PowerShell to achieve the end. Here's a modified version of it adapted to our reverse shell, replace your IP where needed. So let's chuck this in, if I got Sublime anywhere. That's my root box, isn't it? So, who are my groups? Find label. Yeah, so this is my high box. So let's cancel that. And let's start another listener ready to go. And then this one, let's save it as a new folder, bypass, UAC, PS1. Oh yeah, we found this the other day that soldering PowerShell isn't one of the things that it does. Let's try batch file. So what we got? Right. Patches then. So this is what we need to change. So 10.4.8.74.142. So let's see if we can just copy the whole thing in. PS. Look at it in the PowerShell. It still found the threat. So now it's doing some complete fuckery. What's going on now? Didn't catch a shell. Right, let's try it one by one. Start the process. Didn't catch it that time, but it doesn't look like it's doing anything. This exploit creates a new prog ID with the name .pawn and associates our payload to the command used when opening such files. It then points the current vert entry of MS settings to our own .pawn prog ID. When FOD-helper tries opening an MS settings program, it will instead be pointed to the .pawn prog ID and use its associated command. This technique is more likely to evade Windows Defender since we have more liberty on where to put our payload as the name of the prog ID. Oh yeah, good shout. Thank you, Ghost. So this is more likely to evade the Windows Defender since we have more liberty where to put the payload as the name of the prog ID that holds our payload is entirely arbitrary. 6 minutes left, yeah. Let's start a new reverse shell on our attack machine. So did it want me to do that in a elevated shell? And execute the exploit from the backdoor connection as it is. As a result, the defender will throw another alert in the reference. Okay, so it is supposed to error, that's good. It'd be nice if it just said, like, this is gonna fail. How is there no threats? You just found one. There we go. So this time, see the details. This is the current version this time. How's your RDP connection that fast? I don't know. I'm running this on my Kali box though, so it's not the... It took me like a decade to do this. Yeah. Although we're still detected, it's essentially It's essential to note sometimes detection methods used by AV are implemented strictly against the published exploit, without considering variations. We translate the exploit from PowerShell to use CMD, the AV doesn't raise the alert. You replace your IP where needed. This room's really good actually, I quite like this box. So it shows you like one speed based or race condition that you can screw over AV. And now it's saying, oh yeah, just like take the known exploit, convert it to another language, and then it works. Like, it's so good. Alright, so let's see. So it's not going to clear, is it? Because it's a SOCAT. Alright, so we do that one. Oh, it might help if I put my IP in. Which I should probably know off by heart by now. 10, 8, 7, 4, 1, 4, 2. And we re-add the registry key. Re-add the other key. And FOD helper. Ow. No alert this time. So can we actually see that key is still set? We go. So this time it's MS settings. Key current user software classes MSC. Oh, there we go. Just had to refresh. So yeah, it has set it. Well, my opinion of Windows Defender has just gone downhill. That's really bad. So let's have a look then. So we do who am I, groups, find label, high avail. Yep, cool. So we got the high shell. Keep in mind the flag will only be returned if you have the high shell. So as a result of executing the exploit, some artifacts were created on the target system, such as registry keys. Again, so we had these earlier, so we can get rid of them. Do you want to delete it? Yes. Yes. Why does that come up when it's forced? No. Be sure to execute the given commands to avoid the artifact interfering with following tasks. Right, so now we're doing UAC environment variable expansion. Let's drop this shell. Go away. So now we can bypass always notify. As seen in the previous task on the Windows configurations, you can abuse applications related to the system configuration to bypass UAC, as most of these apps have the auto elevate flag set in their manifest. However, if UAC is configured on the always notify level, FOD helper and other apps won't be of any use as they'll require the user to go through the UAC prompt to activate. This would prevent several known bypass methods to be used, but not all hope is lost. For the following technique, we'll be abusing the scheduled task, and they can run as any user. And the music's just stopped because it's done. For the following technique, we'll be abusing a scheduled task that can be run as any user, but will execute with the highest privileges available to the caller. Scheduled tasks are an exciting target. By design, they're meant to be run without any user interaction, independent of the UAC security level, so asking the user to elevate a process manually is not an option. Any scheduled tasks that require elevation will automatically get it without going through the UAC prompt. So we can use the disk cleanup scheduled task. Be sure to disable Windows Defender for this task. That's not as fun, is it? So let's turn it off. Meow. Just run the provided shortcut on your machine's desktop to disable it. To understand why we're picking disk cleanup, let's open the task scheduler. Right, so if we look at the library, Microsoft Windows disk cleanup. As we can see from this task, it's configured to run with the user's account, which means that it will inherit privileges from the user. So who's it being run as? Run with the highest level of privileges. The run with highest privilege option will use the highest privilege token available to the user, which is the high IL token for admin. Notice that if a non-admin invokes it, they'll be given a medium IL. This is only since the highest privilege available to a non-admin is medium, therefore the bypass won't work. But the chances are an admin has set up the disk cleanup. So here we can see, if we check on the actions in the settings, see what it runs. So it's doing manage cleaner, auto clean on the system drive. Allow the task to be run on demand. Since the command depends on environment variables, which we might be able to inject commands into, so like that, we can change system drive and the WinDir. We might be able to inject commands through them and get executed by starting the disk cleanup task manually. Luckily for us, we can override WinDir variable through the registry by creating an entry in HCU environment. If we want to execute a reverse shell using SOCAT, we can use the WinDir as follows without quotes. Uh, 10.8.74.142. So let's see, that will run. Why do I want it to run SOCAT there though? Just that might help if I put the listener on. At the end of our command, actually I'll probably need that space at the end. At the end of the command, we concatenate rem, ending with a blank space to comment whatever is put after WinDir When expanding the environment variable to get the final command used by disk cleanup, the resulting command would be sure to replace your ID. So okay, so we change it there. So delete all that crap I put in. So now it's going to run socat, and then it's going to stop my command, and it's going to do the clean manager auto clean system drive. Anything after the rem is ignored as a comment. So that just gives us a medium shell. So we can stop that. Start another one on 6. So we'll now connect to the backdoor provided on port 9999, which we were doing anyway. Finally, run the command and write the payload to WinDeer. .8. How many times have I typed my IP this time around? 142. Right, so that's creating an environment variable called WinDeer, setting all this data to it. And now we can run the scheduled task, and because we've overwritten WinDeer, it should be called up here. Hey, cool. So now we've got the high one. See it running the thing in the background there. So you should obtain a shell with high IL. Retrieve the disk cleanup flag, to, which we need. That. Keep in mind the flag will only be returned if you have successfully bypassed UAC via disk cleanup. As a result of executing the exploit, some artifacts are created on the target system in the form of registry key. To avoid detection, we need to clean up after ourselves. Alright, last one. Automating the UAC bypass. An excellent tool available to test for UAC bypasses without creating exploits from scratch is created by Firefox. UAC ME provides an up-to-date repository of UAC bypasses that can be used out of the box. This tool is available for download. Nice, we'll be getting that. While UAC ME provides several tools that will focus mainly on one called Agagi. Agagi?
Thank you for the subscription.
Oh, dude, thank you for the 2 gifted community subs to Mr. Longpig and Madicus Maximus. You can enjoy putting my face in chat.
Thank you for the subscription.
Give Nick a shout out as well while he's here. So, should check out Nick. Awesome dude. He's been. What game is that? He's just been playing Star Citizen. So, and he does a lot of Tri-Hackney stuff as well. So Shadow Warrior 2. I thought I deleted that clip. Yeah, you've got better clips, we all know this. But yeah, Nick's a legend, really helpful guy. Does the exact same as what I'm doing now, so. So to use the tool, it's straightforward. You just indicate the number corresponding to the method to be tested. A complete list of methods is available on the GitHub subscription. If you want to test for method 33, you can do one of the following from the command prompt. Okay, so this might make sense if we actually read the docs. So there's quite a few. So you got odd helper. Oh, so that's the one we were just using. Cool. Oh yeah, it's actually just told us. So we can use this tool. Let's paste it in chat so you guys can play with it. So if we get a copy of that, it's just telling me I can use it. So I think that's it for the lab. So if we get rid of these, I can stop that. Let's go to the go to downloads, please. And then we can git clone it. I'll grab a copy of that. There's nothing in bin. Probably got to build it or something. Yeah, there we go. So I need to build it to be able to use it. There must be a release for it. Yeah, there we go. Now the release is the source code. Really helpful. Alright, so I will have to build it. Oh, there, they've got a compiled version, so we can use the one on desktop. There we go, UAC ME Gaggy. So if we just do that on its own, Is that supposed to do anything? Saw something pop up then. I don't know what this is supposed to tell me, if it works or not. Just do the following from a command prompt and a high integrity CMD will pop up. Don't think it will. Well, it's not working now, but it should. So this should just spawn a new terminal with high integrity. So let's skip that for now. I'll figure that out on my own. And then conclusion. We've shown several methods to bypass UAC in Windows in this room. While most of these methods have automatic tools associated, they'll be detected easily by AV on the market if used straight out of the box. Knowing the actual method will give you an edge as an attacker by allowing you to customize your exploit as needed and make them more evasive. As we've seen, UAC isn't considered a security boundary and is therefore prone to several bypass methods. Should you be interested in learning more techniques, the following resources available. So we downloaded that. Bypassing UAC with mock folders and DLL hijacking. That's just a bleeping computer article. And we've got UAC bypass detection, and then reading your way around UAC, whatever that means. Okay, so this is just talking about the process. Okay. Cool. Alright, people can do this room if they want. So, really like this room. This was one of the better ones that I've done. So, bypassing UAC. But there's some really good little techniques in there, so I quite like that. Let's close that. And we should be. Where's the thing? I should be able to terminate the thing. There's no drop down. There we go. Terminate. Shut the room down. And that's one more down. Right, I'm going to take a break from that for a second, and then when I come back, I'm going to fire up the remainder of Dead Space, and we can play the last bit of that. So, if anyone wants to stick around and watch some gaming, we'll do that. If not, you can hop off to an InfoSec stream.